Hey, what is up, guys? This is Josh here coming at you with a brand new video. And so today we are going to be covering inheritance in Java. In the previous tutorial, we talked about classes. And just to recap, a class is basically something that represents a noun. So a person, place, thing, or idea. Inheritance expands on that concept, where inheritance basically means that we have a child class and a parent class associated with it. Right? And this inheritance hierarchy can go as far down as you want. You can have children, and then children of those children, children of those children, so on and so forth, for as long as you need. And a lot of things in programming will use that concept. Minecraft is a big example of that. It uses a lot of inheritance where you have certain generic classes such as block, for example, and then all the different blocks inherit from that generic block class. So, how do we do this here? Well, we're gonna use a game kind of example. So let's go ahead and gonna create a new class. So right click, go to new, and then find Java class. And we are going to name this class game object. So here we are. Right, we have a game object. And each of our game objects is going to have a few different properties that are generic to each of them. Right? So let's go ahead and give this class some private properties. We're going to say each block is going to have a localized or an unlocalized name, I should say, because typically in a game you want to localize something. So public, well, not even public, private string unlocalized name. We're going to have, we want this to be, if we're going to say a 3D object. So we're going to say we want a width, height, and depth. So private double width, private double height, private double depth. Right, so now we have a couple different private properties. This is all we're going to do right now, just so we can get that concept down. Now we're going to create our constructors. So public game object. This is going to be our empty constructor. So this dot unlocalized name is equal to an empty string. This dot width is equal to 0. This dot height is equal to 0. And this dot depth is also equal to 0. And now we need our second constructor. The string unlocalized name, double width, double height, and double depth. And then we're gonna go ahead and copy paste. We're gonna copy paste this here, right? And we're gonna put this in here. Once that's done, change the default values to the names of the parameters. Just like that. And then each of these is we're going to need the getters and setters for them. So we're going to go ahead and say public void set unlocalized name string unlocalized name. All right. And then let's go ahead and copy paste this 3 more times. And go ahead and change it to what we need it to be changed to. So in this case, this is going to be depth. Okay, so we now have our depth here. Excuse me. Next is our height. Just like that. And then now we have our width to take care of. So width. If you really, if you want to, you can skip this part of the video, but it is important that we reiterate how we go through and create these classes, at least the generic way that we do it. Because you're going to find yourself doing this a lot. And repetition, I find, is the best way to learn something. It's the best way to go about actually successfully learning something. So here we are with all of our setters. And we can go ahead and change these then. We're going to copy paste all of these. So then we have all of our getters. And we'll be good to go on that. The nice thing is, when you're creating a generic class like this, with all the properties and their setters, getters, and the 2 constructors, there you can do a lot of copy pasting. So that works in your favor. All right. All right. So I'm gonna separate these here, just for my own sanity. Alright, separate those again for my own sanity. This is going to be set to a return type of string. And get unlocalized name, whereas no parameters. And then return, there. And this one is going to have a return type of double. Again, get. No parameters necessary. Return the width. Another returning of the double. Another get. Just like that. return. So now we just need to change the get method for the depth. So we need to finish this one. So double get, you should be getting it down by now. All right, so now we just need to change this to a return statement once again and return. All right, so once you have that class finished, this is our generic game object class. Pretty simple. Again, we did this in our previous tutorial on classes. And repetition is important in this case because I've actually seen some posts on Reddit in the r/Java help subreddit where people haven't created their constructors correctly. Some people didn't make their methods properly, and that kind of stuff. They didn't construct their class properly. So it's always good to continually create classes this way, and that way it's rammed into your head how to do it, and that will help you immensely. Anyway, all right, so now we need to create a child class. And how do we do that? Well, let's go ahead and right click, go to new, Java class. We're gonna name this block for simplicity. So now we have a block. This is basically like a cube. Think of it as a cube. And this class is going to inherit from game objects. This is going to be a child of our game object class. Now, how do we make this a child of that class? How do we inherit all the code that we just wrote? Well, you would use what's called the extends keyword, as in it extends the functionality of the parent. So, with that being said, go ahead, after block, type extends, and then a space. After extends, put the name of the parent class. There we go. So, in this case, it's going to be game object, right? So, with that being said, now, if we use this keyword, and so we do this dot, you can see we need a constructor for this class first. So let's go ahead and say public block. Right, so we have our empty constructor here. Then if we do this dot, you can see we have access to not only all the generic class functions like equals, clone, finalize, get class, that kind of stuff. You can see we have access to methods like get depth, get height, get width, all that stuff. We have access to all of those methods that we created in our parent class. Because given that it is a child of the parent, that's what it will do. And because we set all of our other our private properties to private, we cannot access them directly from this class. If we want to set those properties, we have to use the setter or getter to do that. And that kind of brings me to another point here. There are a few different things that you can do with your properties. If you need to access a property directly from within a child class, then make it public. However, if you don't want to access them and you only want to access them indirectly via the getters and setters, you need to set them to private. However, there is another keyword that we can use. Now, that keyword is protected. The keyword's called protected. Now, what will happen if we create a protected property in here? Well, let's go ahead and try this out. And we'll go ahead and say protected string. We'll call this texture, right? And we'll go ahead and just say this dot texture is equal to an empty string, right? So this is just a test. We're actually going to have a texture property. Now, if we go into our GameObject class and we try to access it, so this dot texture, you can see we're able to access it directly. And with that, you might be thinking, but Josh, you said that if you want to access the property directly, you use public. And that is true. That's still true. However, the difference between public and protected is that you can only access the protected properties directly from a child. You can only access them within the parent-child relationship. Whereas you cannot access them outside of that parent-child relationship. So if we were to try to access the protected property from our main class, where our public static void main starter method is at, we're not going to be able to access it because it's not because the main isn't inheriting from our game object. So keep that in mind if you want to access your properties of a parent, but only within a parent-child relationship. So that's something to keep in mind, right? So, with that being said, let's go ahead and remove the texture property here. I know protected is a little bit complex. I had some hard time figuring it out myself, but just know protected you can only access directly through the child of a parent. You can't access it outside of that circumstance, whereas public, anywhere can access it as long as you have an object and you're not amending static to it. If you have static added to it, then you can just use the class name dot property name and all that kind of jazz. So, with that being said, if we go back to our block class, right? So we have this. Let's go ahead and inside of this constructor, what we need to do then is we need to call the super. Now, what is the super? Well, the super is basically it's essentially like a method call, except the difference is you're not calling a method name per se. Super refers to the parent class's constructor. And so how do we use the super keyword? Well, like this. So we're inside of our constructor here, right? Inside of our empty constructor. We can go ahead and say super opening and closing parentheses and semicolon. And with that, we are now ensuring that when we initialize a block object, all of our properties that we inherit are set to their default values that we set inside of this constructor here in our GameObject class. Because again, the super calls this constructor. You can also do this with constructors that have parameters, right? So you can say, oh, let's make sure that we have a public block that takes in a double, that's our width, our double of height, and a double of depth, right? So we have that. You can see we don't have properties in our block object directly with height and depth, but we can set them to we can set those properties that we inherit using these parameters by calling the super with parameters. So super, open closing parenthesis, semicolon at the end, and inside of these parentheses we then pass width, height, and depth. However, you can see we're getting an error. Why are we getting an error? Well, because we're not giving it an unlocalized name. So we have that now. And we can pass this in. So unlocalized name. And a comma. Now we don't have any errors. Now that's a pretty simple way of going and implementing all the different properties you inherit from a parent. But you're also going to want to make sure that you know how to implement this class's private properties alongside the super. So let's say this block, it has a top, bottom, left, right, front, and back. Right? So we'll say private string, and we're going to declare multiple variables in a single line. If you don't know how to do this, I'm at this point unsure if I covered this, but if you want to declare multiple variables in a single line, you separate the names with a comma. And they have to be of the same type in order for this to work. So we'll say top texture bottom texture and then we'll say a side texture, just to be simplistic, right? So we have a top, bottom, and side texture. Now, how do we go about assigning these properties? Well, we could say, oh, let's go ahead and define these before we go and call the super. So we'll say this dot top texture is equal to an empty string. That should work, right? Well, it's not going to, because if we see here, we have an error. This constructor call has to be the first thing inside of our constructor. That's just the way Java works. So let's go ahead and go underneath our super. And then we'll say this dot top texture is equal to an empty string. This dot bottom texture is equal to an empty string, and this dot side texture is equal to an empty string. And you can do that inside of our parameter filled constructor as well. But you should know how to do that by now. I'll leave that up to you as a challenge, as well as implementing separate setters and getters for each of these texture properties. Or another thing you could do is you can also have a set texture have a set texture method that will set all three properties at the same time. And then you can have separate getters for each property, which is pretty neat. Now you could also have a get texture and then pass it something, pass it a parameter for getting a specific texture. If you want to, you could do that by using a string or a numbering system, if you so desired. You could do that as a challenge as well to make sure that you understand how this works. But there's also another concept that you could use, but we haven't learned that specific concept yet, so I'll just leave it at that. So that's basically how you create classes that have a parent-child relationship, and how you kind of construct that. So yeah, that basically does it for this tutorial, guys. Thank you all so very much for watching, and we will see you all in the next one. See ya.